Before we can do this lesson, we need to make sure you know what a conjugate is. A conjugate is when you take a binomial and you switch out just the middle sign. You don't switch out the front sign because it's not a full opposite of, but it's just middle sign that changes. So in other words, if you have 3 minus square root of 2, the conjugate would be 3 plus square root of 2. If you have negative 4 minus square root of 3, you would have negative 4 plus square root of 3. Notice the front number does not change, only the middle sign changes. Then you have negative 2 plus 4 square root of 5. The conjugate would be negative 2 minus 4 square root of 5. And then even with complex numbers where you have an imaginary part, you do the same thing, because remember I is just square root of negative 1, so it's kind of similar to these other problems, and you have 3 minus 2i. So those are what conjugates are. Now let's see how we're going to apply them to rationalizing a denominator with binomial denominators. So here's our first example. Notice that the directions might say the words just simplify, and they may just say simplify this fraction. It may just say divide, so 4 divided by 2 plus square root of 5 is what? Or they may say rationalize the denominator. In any of those three directions, just know that you're going to have to rationalize the denominator because we never like an irrational part in the denominator at all. And so the problem with this one is we couldn't just rationalize like we did before, where we take the square root of 5 top and bottom, because the problem with that is we'd have 4 square root of 5 on the top, which is fine, but when we multiply, we actually have to distribute that to both terms when it's a binomial times a monomial like that. And so we'd end up with 2 square root of 5 plus square root of 25. This part would turn out to be 5, which is fine. But the problem is we still have a square root of 5 in the denominator. We just moved it to another position, but it's still there. And so we did not rationalize the denominator. So we're going to have another idea, and this is where the conjugates come in. So we're going to kill this idea. When there is a binomial denominator, this is when you have to use a conjugate. In other words, there's a plus or a minus separating these two things. And so we have to use the conjugate. If it was just a denominator of 2 times the square root of 5, then you would just multiply top and bottom by square root of 5, and that would work fine. But this is not the situation. It's got a plus in between, and that's what makes you have to use the conjugate. And so what we do is we multiply the top and bottom by the same thing, because that makes it legal. And so we multiply the top and bottom by the conjugate of the bottom. So we're going to do it here and the same exact thing on the top. Because remember, if something's over itself, that's just like a 1. And multiplying by 1 doesn't change the value, but the particular 1 that we choose makes it something that is useful for us in this situation. So we are going to multiply and see what happens. Now, multiplying in this case requires on the top distributive property, and on the bottom it is a binomial times a binomial, so we're going to have to do FOIL. So let's do the top first. 4 times 2 is 8, and 4 times square root of 5, one's a radical and one's not a radical. You can't put them together as a 20 or anything. You have to keep them separate. 4 times the square root of 5. Then on the bottom, we get first times first is 2 times 2, which is 4. Then we do the outside. 2 times negative square root of 5 is the way you want to think of that, is negative 2 square root of 5. Then we do inside times inside, the 2 towards the middle, and that is a positive times a positive, so we get positive 2 square root of 5. Then last times last is the last one out of each, and so you get a positive times a negative is a negative, and a square root times a square root, you are allowed to multiply under the square root and get a square root of 25. So that's the first step. We just need to do a little simplification, and then we're done. So a couple of things that happen when you do a conjugate times its conjugate. You end up having this term and this term. When you try to combine like terms, they actually just cancel one another out. They make a 0. and a negative 2 and a positive 2 make a 0, so that's gone. And then the square root of 25, if you picked the right conjugate, it should turn out nice, and this one gives you just 5 if you take the square root of 25. So what we have is on the top we have 8 minus 4 square root of 5 over 4 minus 5, and 4 minus 5 is negative 1. And I'm glad we did this one because negative 1 is kind of a funny thing. Actually, a denominator that's negative is kind of something that's not preferred. We prefer not to have a negative denominator, kind of like we prefer not to have a irrational denominator. And so remember, denominators are how many pieces you're going to divide something into, and to divide it into a negative number of pieces doesn't make a whole lot of sense. So it's better to have a positive on the bottom. What you can do to take care of that is you can just change the signs of everything. It's kind of like you multiplied through on the top by negative 1 and multiplied through by the bottom by negative 1. So if this is negative anything, it doesn't matter if it's a 1 or not, negative anything, what I want you to do is change all the signs of all the terms. And so the 8 becomes negative 8, the minus becomes a plus, and the 1 becomes a positive 1. Now, if that was some other denominator, we would probably just leave it there, but since it's a 1 denominator, anything over 1 is just itself, and so really the top is the most simple way to write the answer, because we can drop off any time we have a denominator of 1. So this one turns out to look like this in the very end, which is a much simpler form of what we had in the beginning. The last thing I want to show you is how to reduce these, and if you were in the quadratic formula section, you'll notice a lot of your answers turned out to be these types of answers as well, and we talked about something called the triangle rule. And basically what the triangle rule is if there's a plus or a minus separating the top or the bottom for that matter, and you want to reduce, you are not allowed to reduce just the 4 and the 8. It has to be all three numbers, and I call that the triangle rule because all three of these numbers have to be reduced at once or none of them can be reduced. And so if there is something that goes into 4, 2, and 8, we can divide top and bottom by that number and reduce it. And there is something that goes into all three of those. 2 goes into all three of those. And so what we do is we reduce this down, divide it by 2 and we get 2, divide this by 2 we get 1, and divide this by 2 and we get 4. And this one reduces to 2 plus 1 times the square root of 3 is just square root of 3, so we'll leave off the 1. And then we've got a 4 on the bottom. You cannot do any more reducing, even though that 2 and that 4 are tempting to reduce. You cannot reduce them because it doesn't meet the triangle rule. And so then on this one, on B, you might look at that and say, well, I can use the triangle rule with the 2 and the 8 and the 4, but that's not what the triangle rule is about. It has to be the number outside the radical. You never reduce something that's outside a radical and something that's inside a radical, so you could never reduce a 2 and an 8 anyways, just because they are, one's inside a radical and one's not. But what you're looking at is the 4, the 3, and the 8, and if all three of them can't be reduced, then you don't reduce any of them. So your final answer is what it is, and this cannot be reduced any further.